Hey, more of the same, guys. Just another take on it, another way of approaching it. So, if you've taken good notes up till now and you're seeing stuff that you've already seen before, just beef this up. So, same topics. Genome. The term genome is a term for all genetic material inside of a cell. So, you carry a lot of genetic material by way of DNA inside of each cell. Okay. This is something we've talked about before, DNA, what the chromosomes are made of. Okay. DNA can meet all of the cell's needs as long as it's small, but when the cell grows too big, you run into that information crisis. Okay. So DNA, the chromosomes are basically extremely condensed DNA, very tightly packed. A sex chromosome determines an organism's sex. Okay, 2 X's for a female, X and a Y for a male. All right, you've seen that before. Autosomes are all the other chromosomes that don't have anything to do with gender. Okay, before cell division, each chromosome is copied. This is what's happening during DNA synthesis. This is what's happening during the bulk of the cell's life. Chromosomes are made of identical sister chromatids that are joined at a centromere. So that the connective tissue right here is what's called a centromere. Okay. So 1/2 of a chromosome is called a chromatid. This is a centromere. Okay, so you can see those 2 chromatids right there, and they're attached to a centromere. Each cell has 2 copies of each chromosome. Those are called homologous pairs. Okay, the copy you get from your mom and the copy you get from your dad are homologous pairs. Humans have 46 chromosomes. Okay, this is a karyotype. The karyotype I showed you in a prior video, it's the very same one. Okay, and you guys know that it's a female with Down syndrome, trisomy 21. Okay, but other than that, it's a normal karyotype. It just takes that extra 21st chromosome to make a big difference. Okay, haploid cells have 1 copy, diploid cells have 2. And that's the abbreviation for haploid. And that's the abbreviation for diploid. Okay, what's the point of haploid cells? 1N plus 1N equals 2N. So a sperm plus an egg gives you the start of a new baby, and then mitosis takes over from there, and cell divide, cell divide, cell divide, cell divide until you have a baby. Yeah. Oops. Okay. So where do each of the 2 chromosomes in a homologous pair come from? One from mom, one from dad. What do we call cells that only have 1 copy of a chromosome? Haploid. What about 2 copies? Diploid. Where are haploid cells found? Okay, in the gametes, sex cells. Where are diploids found? Everywhere else, right? Okay.
Oregon homeowners, all the electric companies are raising their rates, but you can stop them by getting solar panels.
All right, kind of cool.
80,000.
Whoops, I don't want that. All right, I'm gonna go back to my thing here. There we go. All right. So, long story longer, cell division is when a cell divides into 2 or 4 new daughter cells. Okay, 2 in the case of mitosis, 4 in the case of meiosis. Why would they divide? What's the point of dividing if you're a cell? 1, it takes care of that information crisis where you have complete set of DNA that fits the cell. It prevents a cell from getting too big. Remember, they have to stay small because of surface area to volume ratio. Okay. Also, fixing wounds and growth, things like that. Okay. So those are the reasons that you would bother to divide if you were a cell. Okay, and this just shows the lifespan of the cell. We've talked about this before, that interphase, when you can't see any chromosomes, the nucleus is just this tiny little thing, like a little dot, and you can't see any chromosomes. That makes up most of a cell's life. And then the tiny portion of a cell's life when it divides is called mitosis. Okay, the interphase is divided into 2 phases, the G1 and the G2 phase. And this talks about what goes on in the G1 phase, talks about what goes on in the G2 phase. And then you've got mitosis, or in the case of sex cells, meiosis. Cytokinesis in animal cells when they split. Okay? Okay, so that's mitosis, creates 2 new diploid cells. Okay? Meiosis produces 4 new haploid cells. So I would write that difference down. Okay? The result of mitosis, 2 new identical diploid cells. Meiosis, 4 new haploid cells. Notice that I don't use the word identical there, and that's because of crossing over. That's because in some cases your mom's chromosomes go to one end and right alongside with some of your dad's, and your cells wind up going through what's called the law of independent assortment. In sex cells, they wind up all kind of mixed-matched. Okay, so that's a replica. It looks kind of like I'm trying to sell you Amway, but really what it is, it's mitosis on the left side there and meiosis on the right side there. You wind up with 4 daughter cells here, and those daughter cells are all haploid, 2 daughter cells here. There's a great series of video or pictures that show you mitosis. Interphase, prophase, metaphase, anaphase, and telophase. You can always pause this if I'm going too fast. and jot some of this stuff down. I'm going fast because I want to get through it all. And I know that you can pause it. There's the difference between a plant cell and an animal cell is the formation of that cell plate right there. Okay, so can you glance here and see which phase of mitosis we're looking at? What is this one here where they're splitting apart? That's anaphase. There's another one, anaphase, right here. Okay, look at all those chromosomes popping up. You can see them. That's going to be prophase. Okay, so I can clearly see anaphase, anaphase, prophase. A lot of this is just interphase. Okay, most of it's interphase, which makes sense. These are the tips of onion roots. And I think we're